Good evening, everyone. I'm Sangeetha Priya B from the SNS College of Engineering, working in the Department of CSE IoT. In last video, we have discussed about the ARM microcontroller, and this is the continuation of the ARM microcontroller. In the next topic, we are going to see about the bus matrix module. The bus matrix enables the multiple AHV masters from the different AHV buses to be connected to multiple AHV slaves on the multiple ASB slave buses. It enables the parallel access to the number of shared AHP slaves from the number of different AHP masters. The bus matrix determines the masters that gains access to the each slave and rotates the control signal and data signals between them. The block is required in the multi-layer AHP systems. The next one is the SRM and the peripheral. Static random access memory is the type of semiconductor memory that uses the stable launching circuit to store each bit. It is faster and more reliable than DRMA, that is dynamic random access memory, but more expensive than the process. Next one, we are going to see about the features of ARM processor, multiprocessing system, tightly coupled memory, memory management, thumb to technology, one cycle execution time, piping, and a large number of a register. Next topic we are going to see is an ARM instruction set. The instruction set is a neural schema of a processor which enables then any embedded programmer to understand and utilize the processor. In general, the ARM processor classifies its instruction set into a two category: ARM instruction set, thumb instruction set. The ARM instruction sets are 32-bit wide and word aligned. Thumb instruction sets are 16-bit or 32-bit wide. It's aligned on 2-bit or 4-bit boundaries. The thumb is the subset of ARM, and most of its operation maps to the ARM instruction set. The thumb set was introduced to reduce the code size. The processor can execute either the ARM instruction or the thumb instruction by switching the T bit in the status register CPSR. If the T bit is set, the processor in the thumb state and execute thumb instruction. If the T bit is reset, the processor is set to be in the ARM state. Most of the privileged resources are accessed by the ARM instructions. The processor executes the exception handling always in the ARM state. This is the functional representation of the ARM instruction format. The instruction of the three address format, an example mnemonic add D1, S1, S2 performs addition on the source of operand S1 and S2 and stores the result in the destination D1. The 32 bits are divided among the function to be performed and the address of the three operands. The number of bits allocated for addressing the operands depends upon the addressing mode. For example, if the operands use register addressing mode, we need 4 bits to address individual operands. This is the sum of the equation abbreviations which we are using in the ARM instruction set. EQ means equal, NE means not equal, CS or HS means unsigned higher or the same, CZ or LO means unsigned lower, MI means minus, LP means positive or zero, VS means overflow, VZ means no overflow, HI means unsigned higher, LS means unsigned lower or same. GE means greater or equal, LT means less than, GT means greater than, LE means less than or equal, AL means always. The next one is using and updating the condition. To executing the instruction coordinately, we simply postfix it with the approximate condition. Considering the example of addition instruction which verifies the zero flag. For example, an addition instruction takes place in add R0, R1, R2. That is, R1 and R2 is an operand and R0 is the data to be stored. To execute this, only if the zero flag is set, we use added q r0 r1 r2 equal to r0 equal to r1 plus r2 if zero flag is set. The flag or the reflection of the previous execution. By default, data processing operations do not affect the conditional flag. The only instructions that update the condition flag is the compare. To causes the condition flag to be updated, the S bit of the instruction need to be set by the postfixing the instruction and any conditional code with an S. For example, to add two members and set the conditional flag, add 0 or 1 R2, that is R0 equal to R1 plus R2, and set flag. The conditional execution helps to reduce the number of instructions needed to write the program for the specific algorithm.